So we've been talking about what happens when we add things to water. And water has a natural equilibrium between H and OH. And if my water is neutral, both of these concentrations are 1 times 10 to the negative 7th. Okay, and when I multiply them together, I get 1 times 10 to the negative 14th, which is my kW for water. So notice, that is really, really tiny. We're hardly making any H's or OH's. Now, because this is straight multiplication, there's no denominator because water's liquid. When one goes up, the other must go down because we have to keep this equilibrium of 1 times 10 to the negative 14th. So if my H plus or my H3O plus is 1 times 10 to the negative 2, my OH must be 1 times 10 to the negative 12th. Now, when we have negative exponents, this is 0.00, that's not right, 0.01, and this is 0.000001. You can see that this negative 2 is a much larger number than a negative 12 exponent, and so our H pluses are greater in solution, which makes it an acidic solution. In a basic solution, my OHs are bigger. So when we do negative exponents, remember the lower the negative exponent, the bigger the number. So if I have more hydroxides than hydronium ions, my solution will be basic. So now instead of looking at concentration, we're going to look at pH. So remember, concentration is molarity. Okay, and these brackets mean concentration. And I just want to go through the negative exponents again. So negative 1 is 0.1, 1 times 10 to the negative 2 is 0.01, to the negative 4th, 0.001. Bigger negative exponents mean a smaller number. And our pH scale is how we convert these powers so we can compare these numbers easily to the power of 10. So when you see P in chemistry, there's pH, POH, pKa, which you guys won't do. P means negative log. And basically I'm taking these numbers and I'm just figuring out what the power of 10 is. So pH equals the negative log of my H concentration. So you're going to put in your H concentration. Usually you're going to hit log. It will be a negative number. That negative will make it positive. Okay, so practice that with your calculator. And then there's also the POH, and basically I'm just doing the same thing with my hydroxide concentration. So if my H concentration is 1 times 10 to the negative 1, a pH of 1, to the negative 2, pH of 2, to the negative 4, pH of 4. Now I can do that in my head because this first number is 1. If that's not 1, you're going to have to put it in your calculator, okay? So notice, as I go this way, I have decreasing H concentration, which means I have decreasing acidity. So a pH of 1 is acidic, and a pH of 14 means I have hardly any hydroxide, I have hardly any hydrogen ions, and so that's basic. That's why that end of the pH scale is basic. So basically, if this and this is 1 times 10 to the negative 7th, to make that perfectly neutral 1 times 10 to the 14th water, and I turn it into my pH and POH, I can do pH, which is 7, and POH, which is 7, equals 14. So here is our second formula. So now we have these two formulas to use. And this is our concentration box. So if I want to go from H to OH and pH to POH, I'm going to use these formulas. So I can convert from my hydrogen ions to my hydroxide ions using this formula, which you have done. I can also convert from my pH to my POH by using this formula, pH plus POH equals 14. Now when I go down, if I want to go from my hydrogen ion concentration to my pH, pH is the negative log of the concentration of my hydrogen ion or hydronium. If I want to find my pOH, pOH is the negative log of my OH concentration, okay? Remember, check that with your calculator. Make sure that when you put in 1 times 10 to the negative 7th, you're going to get a pH or a pOH of 7. Going backwards, it gets a little tricky, and we won't be doing that very often. However, going backwards, you want to use what I like to call the inverse function or the second log function. And what that is my OH concentration equals 10 to the negative pOH. So if I look here on my log, I have this 10 to the x. So you would put in your number and put second function log, or depending on your calculator, you might have to put second function log and then put in your number. So you want to double check that. Okay? So, something else to think about. Because my pH is a power of 10, each jump that I make, pH of 2 to pH of 4, that's 2 units, so that's a jump of 10 times 10, which is 100, so that's a jump of 100. Okay, if I go from a pH to 2 to a pH to 4, I become lower in my H concentration, so it becomes less acidic. IU asks this question every single time, okay? They want you to go through jumps, and they want you to say if it's increasing or decreasing acidity. So if I go from a pH of 5 down to a pH of 2, remember 14 is basic, 1 is acidic, so this is getting more acidic. And I went from 5 to 2, that's 3 magnitudes of 10, so 10 times 10 times 10, that's 1,000, or 3 zeros after there. Okay? The other question they like to ask is what is most acidic, and they give you all of these things. Okay? So what you're going to do is you're going to take pH of 5 is a pH of 5. We're going to compare it by pHs. OH concentration, how do I get to pH? Well, I have to take that concentration and find my pOH, and then I have to convert it to pHs because we're comparing pHs. Okay? Here I have my H plus concentration. I can turn that right to a pH, and I have a pH of 1.3. So now when I put them all in pHs, I can compare them. I have a pH of 5, pH of 11.3, pH of 1.1. This guy is the most acidic.